He kōna ipurangi tēnei nā te reo irirangi o Aotearoa.
Kia ora and welcome to Elemental from RNZ. I'm Allan Blackman from the Auckland University of Technology.
And I'm Alison Ballance. And this is episode 66, meaning we have left the P's of the periodic table behind and are heading into the brave new world of the R's, bringing us first to...
Ta-da! Radium, from the French word radium, formed in modern Latin from radius, meaning ray.
As in a ray of sunshine?
Well, not quite. It's actually in recognition of radium's power of emitting energy in the form of rays.
Details, please.
Okay, so vital statistics, elemental symbol Ra, and a whole lot of 8s, so atomic number 88, and it was discovered in 1898. So, we have already discussed radium very, very briefly in the Curium episode, as it was originally isolated by Marie and Pierre Curie. More recently, we've also touched upon it in the polonium episode for the same reason. Despite the fact that it is extremely rare, it is an element that many have heard of owing to the Herculean efforts made by the Curies to isolate it. So I guess let's have a little history lesson and go back to the time where they were working with this, and that was 1896. And just consider for a moment that radioactivity was only discovered that year. It was brand new. So the Curies were, like many of the people we've talked about, in exactly the right place at the right time to make an earth-shattering discovery.
Well, they made several, actually, didn't they?
Oh, yes, they did, indeed. But I guess radium is easily the most famous of them. This is one element that everybody knows about. So let's have a look at radioactivity itself, and it was discovered by Becquerel in 1896. And the way he discovered it was he took a uranium salt and he put it on an undeveloped photographic plate, which was all wrapped up in dark paper and stored in a drawer, and he found that the plate actually darkened, despite the fact that it was in the dark the whole time. And so he postulated that obviously something was going on there, it was giving out some sort of rays. And as a result of Becquerel's work, then the Curies started working on pitchblende, and that's a uranium mineral now we call uraninite, and that consists primarily of 2 uranium oxides, uranium dioxide UO2, and a small amount of U3O8. And what they found was that the radiation emanating from this material, the pitchblende, was in fact greater than could be accounted for on the basis of uranium being the only radioactive element present in the pitchblende. And so that led them to, I guess, literally go digging in the pitchblende to find out what else was in there. And as we now know, it was both radium and polonium that were in there. This took them sort of a couple of years of work to identify radium, and they got there in 1898. And then they started going on the big scale, and they processed literally tons of pitchblende to end up with, in the year 1902, exactly 0.129 grams of a mixture of barium and radium chloride, in which around 1 atom in 1,000 was radium. So they'd finished that, and this whole discovery formed the basis of Marie's PhD thesis, which was submitted the following year in 1903. Needless to say, I guess, because radioactivity was a new phenomenon, its dangers were not at all well known. And so people were getting and studying this stuff and doing things that we wouldn't dream of doing today with no radioactive protection at all. And indeed, Pierre once wrapped a sample of radium salts to his arm for 10 hours and then studied the resulting radiation burn. And I know. And after day 52, a permanent grey scar remained. What he took from this experiment was that radium might be used in cancer treatment.
Didn't occur to him it might cause cancer?
It didn't occur to him that it was slowly killing him, very probably, unfortunately. So when Pierre met his untimely end on a Paris street, as we've already talked about it, he got run over by a horse carriage. It was thought that he was very, very ill with radiation poisoning at the time.
So what sort of uses have we actually put radium to?
That's the interesting thing, because when it was first discovered, it was put to an absolute myriad of uses, as we will talk about. So The first and most obvious thing is that radium salts have this wonderful capacity to glow in the dark. And so instantly, radium salts were used in luminous clock and watch faces, and the workers in the factories that made these used to paint the radium on the dials by hand. And not too surprisingly, many of these workers came down with radiation poisoning. And the most infamous examples were the radium girls. And they were encouraged to point the brushes with their lips to stop them going out of shape. They were told to lip dip and paint the radium on these dials.
Ooh.
So, not surprisingly, a lot of them started getting sick, and some dying workers sued their employer in 1927 and won. Like all court cases, it was appealed a total of 8 times, and it went all the way to the US Supreme Court, and they actually did refuse to hear it, but that took 10 years to get there. And sadly, radium was still being used on luminous watch dials until the late 1960s, the only difference being that the workers were told not to lick their paintbrushes. God help us. And then radium was replaced by promethium, as we talked about a couple of episodes ago, and then still later by tritium.
For a while, radium was promoted as having life-giving properties, wasn't it?
Yeah, that's the thing. All these mysterious rays were thought to be good for you. So because of that, radium was added to things like water or coffee or beer, most disturbingly face creams, before it was finally figured out that it was bad for you. And this is an absolute tragedy. A very famous case of radium poisoning was that of a guy by the name of Aben Bayers, and he was a US steel magnate. He believed in radium so much that he drank radium-infused water every day for around 4 years, and not surprisingly, he ended up with cancer of the jaw and very, very bad radiation sickness, and that ended up sadly killing him.
What makes radium so poisonous to us?
Well, it's very, very dangerous because of its position on the periodic table. It is in group 2 of the periodic table. It's a metal. And another element that appears in group 2 is calcium. And hopefully, as listeners know by now, elements that appear in the same group have similar chemical properties. And so therefore, to the body, a radium atom does look a little bit like a calcium atom. And so therefore, if you do ingest radium, it will localize in the bones. It'll stay there, and then its radioactivity will do you nasties.
Well, thank goodness we're no longer sipping or soaking in radium water. Do we actually have any safer uses for it these days?
Well, that's the funny thing. It is a really, really famous element, but it is rather devoid of uses these days.
It'll never not be a famous element, though, will it? Hey, interesting fact, please.
Okay, so the old non-SI unit of radioactivity was a thing called the Curie, and that was defined as the amount of radioactive material that had the same decay rate as 1 gram of the radium isotope radium-226. And that is, in fact, 3.7 times 10 to the power of 10 disintegrations per second. That's 37 billion disintegrations per second. And that really does sound like a huge number. Like that's 37 billion. But let's put this into perspective by the fact that if we take that 1 gram of radium-226 and wait for it to decay completely, that's in fact going to take 16,000 years, decaying at a rate of 37 billion disintegrations per second. And the reason why it's going to take 16,000 years is that in that 1 gram of radium, we have got around about 2.66 times 10 to the power of 21 atoms.
Of course. Elemental, a podcast juggling mind-boggling numbers and concepts with consummate ease. And I have to say I'm referring to you with that sweeping statement, Alan, rather than myself.
Oh, Alison, why thank you. Goodness, I am very happy to take any compliment given, believe you me. And yes, we have covered other episodes of Elemental with equally mind-boggling numbers. And yes, you can hunt them down on your favourite podcast app.
Or find them online at rnz.co.nz/chemistry. Next time, we're investigating radium's daughter element, radon. But until then, it's goodbye from me, Alison Balance.
And me, Allan Blackman. Mā te wā.
by the way, Alan, Brazil nuts. I meant to talk with you about radium and Brazil nuts.
Oh, yeah, sure, that's right. We mentioned Brazil nuts in the barium episode because they're high in barium.
Yeah, and they're high in radium too.
Ah, those group 2 elements. Aha, see, that reminds me of the banana equivalent radiation scale on the potassium episode.
Oh, that was a good one, wasn't it?
Oh, they're all good. Come on.